Hello children, hope you are all doing well. Today we are going to start with our first chemistry chapter, which is chemical reactions and equations. In this part of lesson, you would be able to define a chemical reaction, understand the science which helps to determine whether a chemical reaction has taken place, and express a chemical reaction through a chemical equation. I have also attached a video link in description box on the topic physical and chemical changes, as this lesson requires the prior knowledge of physical and chemical changes. You can check the video for detailed explanation. Consider the following process. The first image shows the rusting of iron. You know that rusting of iron is a chemical change, as iron combines with oxygen to form the new substance iron oxide, and it's an irreversible process. The second image is that of respiration. Respiration is a biological process. In this process, oxygen-rich air is inhaled. This inhaled air reacts with glucose present in the cells of the body, forming carbon dioxide and water. Hence, respiration is also a chemical change. So, have you ever wondered how these chemical changes occur? Or what brings forth these chemical changes in these various processes? In general, chemical changes occur when a substance combines with another to form a new substance. In case of rusting of iron, iron combines with oxygen present in air in the presence of moisture to form iron oxide. Or alternatively, the substance chemically breaks down into two or more substances. In case of respiration, the glucose present in the cells combines with the inhaled oxygen to form carbon dioxide and water. So such process, that is here in the case of rusting of iron, chemical synthesis took place, and here in the case of respiration, chemical decomposition took place. So such processes are called chemical reaction. So whenever a chemical change occurs, we can say that a chemical reaction has taken place. Here, iron converted into iron oxide, a totally new substance, and here glucose has broken down into carbon dioxide and water. So in general, chemical reaction is a process in which one form of chemical substances is transformed to another form with new properties. So next, let us observe few activities. The first one will be burning of magnesium. Second one, reaction between lead nitrate and potassium iodide. And the third one, reaction between zinc and dilute sulfuric acid. So let's observe these activities and understand the chemical reaction taking place during these experiments. So, as said, first experiment is burning of magnesium ribbon. So here is the activity. We have to take almost 2 cm long magnesium ribbon and using a sandpaper rub and clean it. Then we have to hold the ribbon using a pair of tongs and burn it using a burner. The reason why magnesium must be cleaned before burning in air is that in order to get the desired chemical reaction, we have to remove the layer of magnesium oxide formed due to the reaction of magnesium with air. So, before getting into detail of its chemical reaction, let us watch a video on this experiment. So, here is your video. So, you can see that a magnesium ribbon is held with the help of tongs and it is burnt using a Bunsen burner. You can observe magnesium burns with a dazzling white flame. It looks so beautiful, isn't it? Now, as the reaction gets completed, you can see that a white color substance is formed. Now, if we collect this white color substance in a watch glass and analyze it further, you can see that this white color substance is a powdery substance. So, what were the observations we made here? When magnesium ribbon burns, a dazzling white flame is produced and a white powdery substance was formed after the completion of the reaction, which was collected in a watch glass. So, let's see what's a chemical reaction occurred during the burning of magnesium. Now what happens here is magnesium burns in presence of oxygen, that is magnesium combines with oxygen to form magnesium oxide. This magnesium oxide is the white powdery substance, that is the white powder which formed after the completion of the reaction is chemically magnesium oxide. So in short, we can represent the reaction as magnesium plus oxygen gives magnesium oxide. Experiment number 2, reaction between lead nitrate and potassium iodide. So here we have your activity. At first, aqueous solution of lead nitrate and potassium iodide is prepared in 2 different test tubes. Then the aqueous solution of potassium iodide is added to the aqueous solution of lead nitrate or vice versa. So again, before discussing the chemical reactions involved, let us watch a video. So here is your video. So here we have lead nitrate and potassium iodide. What else we require is a few test tubes and water to prepare the aqueous solution. Aqueous solution of a substance is prepared by dissolving a small amount of substance with water. So we start with preparing the aqueous solution of lead nitrate. Here we take a small amount of lead nitrate and transfer it to the test tube. You can see that the color of the lead nitrate is white color. Then we will take the other test tube, and to that test tube we will add a small amount of potassium iodide. Again, you can notice the color of the potassium iodide is white in color. Now we have to prepare the aqueous solution of both potassium iodide and lead nitrate. So here in the test tube containing potassium iodide, we add a little bit of water and shake it well so that it dissolves completely. Similarly, in the test tube containing lead nitrate, we add a small amount of water and again we shake it well so that it dissolves completely. Now you can see that in both the test tubes a clear solution is formed. Here you have the lead nitrate solution and here you have the potassium iodide solution. Now we will add the lead nitrate solution to the potassium iodide solution. Here we go and see what happens. Amazing. You can see a very bright color yellow precipitate is formed. From 2 colorless solution we got a yellow color solution, yellow color precipitate. So what are the observations made here? A yellow color precipitate is formed. So how does the yellow color precipitate formed here? What was the chemical reaction involved in this process? So what happens here is lead nitrate reacts with potassium iodide to form lead iodide and potassium nitrate. The yellow color formed after reaction is due to the formation of precipitate lead iodide. So in short, the reaction can be written as potassium iodide plus lead nitrate gives potassium nitrate and lead iodide. And the yellow color of this solution or the yellow precipitate formed is due to the formation of lead iodide. Potassium nitrate remains dissolved in the solution. Experiment 3, reaction between zinc and dilute sulfuric acid. So here is the activity. First we have to take zinc metal granules in a boiling tube. Then add 5 ml of dilute sulfuric acid to the boiling tube containing the zinc granules. After a while, when the reaction has begun, we have to bring a burning matchstick near the mouth of the boiling tube. Let us watch the video first. So here is your video.
Materials required: boiling tube with holder, zinc metal granules, dilute sulfuric acid, dropper and matchbox. Procedure: take some metal granules in boiling tube and pour dilute sulfuric acid in boiling tube. there will be a reaction occur between zinc metal and sulfuric acid. Now lit a matchstick and held near the mouth of the tube. You will observe that there is a pop sound, and this pop sound confirms that the evolved gas is hydrogen.
I hope the video was very informative. The observations made here are: the matchstick is put off with a pop sound. Bubbles are seen rising from the bottom of the test tube, and the test tube is warm when touched. So if we analyze the reactions taking place, the matchstick is put off with a pop sound, which confirms the gas produced is hydrogen. The bubbles are seen rising to the top is due to the liberation of hydrogen gas. And when we touch the test tube, we feel the warmth, and that is because of the release of heat energy. So in short, the reaction can be represented as zinc plus sulfuric acid gives zinc sulfate plus hydrogen. After observing the following three activities in the previous slides, you should have understood that there are certain observations which helps us to determine whether a chemical reaction has taken place or not. So here are the following observations or signs which helps us to determine whether a chemical reaction has taken place. They are change in state, change in color, release of gas, change in temperature. So these are the signs of chemical reaction. If you recall the reaction between potassium iodide and lead nitrate, you saw that when aqueous solution of potassium iodide and lead nitrate were combined, it produced an insoluble yellow solid. That is, a yellow precipitate was formed. So here the liquid converts into solid, which indicates the change in state. For the same reaction, you notice that two colorless solutions changed into yellow precipitate, indicating the change in color. Similarly, if we recall the reaction between zinc and sulfuric acid, zinc reacts with sulfuric acid to form zinc sulfate and hydrogen. So there is a release of gas. And also the reaction is accompanied by the release of heat energy, which indicates a change in temperature. If we consider the reaction, when a magnesium ribbon is burnt in oxygen, it gets converted into magnesium oxide. The word equation for the above reaction can be written as magnesium plus oxygen gives magnesium oxide. A word equation shows change of reactants to products through an arrow placed between them. The arrowhead points towards the products and shows the direction of the reaction. The reactants are written on the left hand side with the plus sign between them. Similarly, products are written on the right hand side with the plus sign between them. In this reaction, magnesium and oxygen are the reactants, and the new substance magnesium oxide formed during the reaction is the product. So, in general, the substances that undergo a chemical change in the reaction are called reactants, and the new substances formed at the end of the chemical reaction is called products. Consider the word equation zinc plus sulfuric acid gives zinc sulfate plus hydrogen. Replacing the word equation by the chemical formula of the reactants and products, we have Zn plus H2SO4 gives ZnSO4 plus H2, that is zinc plus sulfuric acid gives zinc sulfate plus hydrogen. This very short and simple way of representing a chemical reaction is known as chemical equation. So chemical equation is the simplest way of representing a chemical reaction. A chemical equation consists of reactants and products with an arrow mark indicating the change of reactants to products. The reactants and products are written in terms of their chemical formula. Let's take another example. Potassium iodide reacts with lead nitrate to form potassium nitrate and lead iodide. The chemical equation for this above reaction can be written as PbNO3 twice plus Ki gives PbI2 plus KNO3. That is, lead nitrate plus potassium iodide gives lead iodide plus potassium nitrate. Here is another example. Magnesium reacts with oxygen to form magnesium oxide. The chemical equation for the above reaction can be written as Mg plus O2 gives MgO. That is, magnesium plus oxygen gives magnesium oxide. So I hope you guys have understood what is meant by chemical reaction and how to express a chemical reaction through chemical equation. I will be back with another video on the next topic of this lesson, which is balancing of equation. Thank you, children.